Hello everyone. So in this lecture we will move on to the processing of graphite ores. So now you know the basic properties of carbon materials, and let's now talk about the natural graphite. I told you that we find this natural graphite mostly in sedimentary or the metamorphic rocks. But once you get it out of the rock, what do? Okay. Now, first of all, the major graphite producing countries, I have mentioned a few names here. There may be some more countries. Now, in some countries, you have graphite mines, and the quality of graphite also that you find in different countries may be different. In some of the countries, the production of synthetic graphite is more, and some countries will produce both. So, the synthetic graphite we are going to cover only in the next lecture. Today, we are going to talk about the natural graphite, mainly the ores. So, first of all, what is an ore? Again, when you find something in the rock, that complete mixture of your mineral as well as the other impurities, so that entire mixture is what you call an ore, the first basic material that you get from a rock or mine or wherever. Okay. Now, are all graphite ores the same? The answer is no. We will have different types of graphite. In fact, based on the quality, based on the crystal size, how we can now classify these different ores. For example, the first one is known as the vein or lump graphite. Now, this is the highest quality graphite, and the quality is, of course, decided by A, the crystal size, and B, the purity. So this kind of graphite, which is mainly found in Sri Lanka. Sri Lanka is one of the largest producer of this. It's very expensive and it's very rare. The crystallite size is often above 500 micrometer. So above 500 micrometer means you can, physically you can take in your hand a single crystal of graphite. So that is already large enough. In the case of other minerals, maybe you can have several centimeters long crystals. But in the case of graphite, if your crystallite is, in a millimeter range, then that is pretty large. So this is one of the most expensive graphite. And of course, this is only used for very high-end applications where you need very high purity, where you need very high, good quality, and you don't care about the cost. For example, I was mentioning this nuclear reactors and so on. So in these kind of high-end or device applications, for example, you will use the lump graphite. However, the most commonly used graphite for manufacturing purposes is the second type, which is called the flake graphite. So depending upon the mineral, you have the purity between 80 and 95%. And the crystal size is medium. It's not very small, but it's also not very large. This is the most commonly used industrial graphite mineral. And the third one is known as amorphous graphite. Now again, amorphous. Graphite is not amorphous, right? Graphite is crystalline, and we use it for all of its crystalline properties, its electrical conductivity and so on. But it is called amorphous because it's found in such small pieces that it looks like a powder. You will also hear the word powder graphite. So this just because the crystallite size is very small. And it also contains a lot of impurities, so it is often found in the form of a powder, and any powder can be called amorphous. So that is why it is commonly industrially known as amorphous graphite. Now, this is a seam mineral. So I told you that you can find graphite in coal seams. These kind of graphites are generally found with other forms of carbon or petroleum. So they are often formed under high temperature conditions, and that is why you also can find some ash. Ash is something where whatever is left after your material is burnt. This is the definition of ash. But it often happens that people, when you use a high temperature process for processing your carbon material, which we will learn, which will multiple times we are going to talk about that, when we convert an organic material into carbon by getting rid of the non-carbon impurities. And how do we do that? By heating it. So often what happens is when you are heating something in a furnace, people end up calling it burning. So just make sure that you don't do that, because burning can only take place in the presence of oxygen. What is burning? Burning means oxidation. So if you are heating something in the furnace in the absence of oxygen, then that should not be called burning. Burning leads to ash formation. And in fact, in some cases where if you end up, by mistake or for any particular reason, because of cost reasons or whatever, you end up having some oxygen in your furnace, then you often get a lot of ash content, which can also clog your systems, and this can also be a problem. Okay, anyway, so these are the three types of graphite that we have. Okay, now what are the type of impurities that our graphite minerals contain? So if you find something in a rock, how will it look like? It will contain some of these what are known as clay minerals. So you have sand, of course, so you have certain silicates. Okay, now you will also have clay minerals. Actually are rock forming minerals in very general terms. And however, they are often formed in the presence of water. So they are hydrous rock forming minerals. So you will find these minerals maybe now they may actually be trapped inside the layers of graphite. Sometimes they may lead to they may create a stacking fault, or they may create any other types of defects. Sometimes you have two small crystallites of graphite and you will have the impurities trapped between them. Sometimes they will be sticking on top of the surface. So however, in most of these cases they are physically attached to graphite and not chemically. So when you're doing the processing of graphite, you will typically only use the physical separation methods and not chemical any chemical process, because for example, in the case of iron, you will have sulfides or calcium in the form of calcium carbonate you will have. So carbonates and sulfates and so on. Then you have to utilize chemical processes to remove these things. But in the case of graphite, it's very simple. You'd only have the physical separation processes. However, one thing that you need to ensure that you don't end up reducing the size of your crystal very much, because graphite's value is because of its crystal size. Now in some mine you find really large crystals and then you end up making them very small. Then that should not happen. So this is something that we need to make sure that we don't induce defects, because that also influences the properties of your material. Okay, now all of these physical separation methods which we are going to, or physical or chemical, all these separation methods which are when you move from the ore to your pure metal. So if I draw an arrow, whatever processes that you use, they are known as beneficiation. So you're actually improving the value of your ore at each individual step, and at the end you get your metal. So graphite is not a metal. It is a mineral, but it is called semi-metal. It's not a metal. So however, this beneficiation process is what we are going to learn in our next couple of slides. Okay, now since most of these properties of physical separation, most of these methods, you need to make one property becomes very important for you, that is the surface property of your material. Because for example, if something is hydrophobic or something is hydrophilic, then you can easily separate them in one medium. So for example, if you have just water and you have a mixture of something that is hydrophobic or hydrophilic, then you just mix it, then something will settle down and something will float. So these kind of methods that we use very often, and that is why the surface properties become very important. Now quickly, thermodynamically speaking, what is your Gibbs function, or what is this process? So when you are separating two things, that means things are mixed. Sometimes you will also intentionally mix them. Not any additional impurities, but basically you will make a very fine powder of your whatever rock you get. And now you want that powder to mix very well within itself. Why? Because so that in your whatever system you're using, you want the distribution of all the particles to be uniform. So you're doing mixing, and afterwards you're also doing separation. So separation, what is separation? Separation is the opposite of mixing. So if you want to consider the enthalpy of a certain reaction, that reaction, let's say this is a mixing reaction, the opposite of it would be separation. So your delta G, or the Gibbs free energy of mixing will be equal to that, delta H minus T delta S. I have not written the delta T term because the constant, we are doing this at constant temperature. Okay. Now for spontaneous mixing, what are the conditions that you have? Your delta G of the reaction should be less than 0, it should be negative, and also the second derivative of your delta G should be greater than 0 with respect to the mole fraction of your different components. So these are the two conditions. Now you can play with these things. You know that this is your thermodynamic the reaction or thermodynamic relationship. And now what you can do is, what are the things that you can vary? You can vary the temperature. That is another variable is the mole fraction. Mole fraction may not always be in your control, because that will, for example, if you're it depends on the mineral that whatever your mineral contains, but sometimes you can also additionally have certain mineral just or certain impurity if you want to play with this relationship, and if you want to purify your material or your ore. Okay, so now we will move on to the actual processing steps for graphite ore. Okay, as I mentioned before, we use the surface properties of the material, or material by material I mean now also the impurities. So we use surface properties, hydrophilicity and so on. But other than that, what is important, if you have any magnetic impurity, for example iron impurities, then that is very easy. You can utilize magnetic forces to separate it out. If you have, you can also use certain electrostatic forces to separate out the impurities. However, you are also using physical separation using water or other kinds of solvents or liquids. In that case, one more property that becomes very important is the specific gravity. What is heavy, what is light? That becomes very important for us. So these are the important properties. Now, I'm going to list a lot of steps, lot of processes that are used for the beneficiation of graphite. But not just remember that not all the processes are used in in all cases. So for example, somebody can choose a certain type of separation method and leave out the other. So not all of them will be used together. But I'm listing all of them because just so you know all of them. Maybe one company is using one set of techniques and the other is using another. However, one common thing is that you will mainly have like 3 stages of this beneficiation. Logically, if I give you a piece of rock and I say that this is graphite rock, and you need to, now the graphite impurities, however, are they are filled all the way inside, even they are trapped between the layers of your crystals. What are you going to do? First, you will make a powder of that of your rock. Why do you want to make a powder? Because you want to, in order to clean these impurities from everywhere, deep inside, you need to increase the surface area of your material. 1, you will make the powder, and 2, you will then do the actual separation, and 3, you will do some final steps, the refining steps. So these are the 3 primary stages. Okay, so the stage number 1 is known as communition. Communition is basically powder making. So size reduction of your usually this is for the rocks. Or if you find big lumps of your ore, then you can do things like crushing, you can do grinding, you can do milling. Common techniques that are used for size reduction. So milling can be also of different types. You can use ball milling, you can also use milling. For example, you can use water as a medium during your milling if you want to make sure that you don't want to damage your sample very much or damage your mineral very much, the crystals. And also you can use attrition milling, you can also use tumbling, for example. So these are all communition techniques, and these are used for graphite, the making the powder out of the rocks. Okay, that part is simple. The second part is where you are actually doing separation of your impurities. So what do you have in graphite? You have sand, you have silicates, you also have clay minerals. Also you may have ash if you have amorphous graphite. Okay. So the first method that we are going to discuss is known as gravity concentration or jigging concentration also used. So this is jigging, commonly known as jigging process. So what is it? This is a method where you, based on the specific gravity, separate the things, but you have a medium like water. So okay, I will show this with this picture. Here I have shown on, there is a moving piston. So you see there are like 2 chambers and water is filled inside it. Now in water, what do you have? You have one moving piston which is constantly moving up and down, and that action in fact is what is known as the jigging action. Now on the other side you see that there is some sort of a filter. It's it's kind of this is a barrier from where only certain size of the particle can pass through, or the particles of certain size can pass through, and others will stay on top. And also these browner bigger pieces also you will sometimes put. It's more like making a physical membrane. Now you have your impurities. The moment you put your piston down, the water level on the other side will go up. Then you remove the piston, the water level goes down. Now this water level is going up and down, up and down. What is happening? Now if you have your mineral in it, mineral contains some light impurities and some heavy ones. Also, however, within the light and heavy, so that is the weight of the, also you will have the different particle sizes of the impurity also. Not all the impurities will be of same size. So what will happen? The lighter ones will float and they will not be able to come back when your water level settles. They will not be able to come back. Only a certain size, the optimum size of the impurities, optimum size and optimum weight will go down. Then again, because the lighter ones, when water level is going up and down very fast, the lighter impurities will continue to float. They may not be able to come back that fast. So this is how you're going to, at the end you will get your whatever is the desired either impurity, or it can also be your graphite crystal. Whatever is the desired material you want at the end, that you can remove. Typically this is, in the case of graphite, this is done for impurities. Also also you use water as the medium. Okay. Now another method would be, it is known as heavy media separation, or it's also one form of it which is most commonly used is also known as sink and float separation method. Okay. So here what do you do? Okay. Instead of water, if I use an oil, or if I use alcohol, or if I use anything which has different properties, which is either lighter than water or heavier than water, then what will happen? There may be certain impurities. So this is also, now you're playing with the specific gravity of the medium. This is a heavy media. This is so heavy medium. Okay. In this case, certain impurities which were floating in the case of water, they may also get settled. So this kind, now here you don't need a piston. Here you you don't have anything else. Typically you just have very simple device which you where you have like a big chamber, and you have certain, what you need to optimize is the specific gravity of your medium itself. So the liquid medium. So here you will have then certain things settling and certain floating. Okay. Now, of course, with these arrows, I have shown the inlets and outlets. So the lighter things, also in the case of jig concentration, the lighter ones, whatever you get out, on the top, you will remove it. Whatever you get on the bottom, you'll remove it. These are very, very, very simplified diagrams. So I'm not really showing you the actual equipment at all. So these are also, I have just made chambers, but often you will have conical shapes. So you will also optimize the design of your chamber such that it's easier to remove and easier to perform these operations. And also that helps the concentration of what you get at the bottom and so on. But this is just a very simplistic view. Okay. What else? You can also have spirals. Spirals, you know how spirals look like. If you can think of a spiral slide, what children have, they slide onto, or sometimes they have these rides in some parks and so on. So those kind of slides you will have also for your for the powder of your mineral. What will happen now? The slide itself, you will have maybe different inclinations in the slide, and depending upon the speed, and that speed will be decided by the weight and size of the particles. So depending upon that, on the different parts of the slide, you can collect different particles. So this is just like, let's say it's a part of the slide, or part of the spiral. At the end, I have made 3 arrows. Typically you can collect in different parts of the slide, you can collect different types of particles. This is also very similar to many techniques which are used in separating the agricultural produce. So you will see that if you have some dal or something like that, then you can separate it out of the husk based on its weight. So these are particle separation techniques, and something very similar you will also use for the graphite powders. This picture that I have shown, this is just the one part, or one very small part of your spiral, which goes on like that. Okay. Now the fourth one is known as air classification. So till now we were using water as the medium, or some liquid as the medium for the separation, and now what we are going to do is we are going to use air. So we can say that this is based on the aerodynamic behavior of the particles. So again, this will depend on what kind of powder do you have, what kind of impurities do you have, and that is why I said that not in all cases you'll use the same types of techniques. In case you have ash, for example, it's much easier to separate it out using the using floating. And so, but for different minerals, or if you have iron, it's easier to do it using using a magnet and so on. Okay, so in the case of air classification, what do we have? We have sort of a chamber, and that chamber has air coming from the bottom, so it's rising air. And sometimes you may even have this pulsating rising air. And now you have your particles, since your powder inside, sometimes in the form of a dry powder, sometimes also as a stream, as a jet, you will spray your slurry. So you have the particles there, and now of course some particles will float and some will settle down. So this is the aerodynamic behavior. That's again a lot of agricultural products, they are also separated. You may have seen that, husk separation also, you can just drop them from a very high place if you have heavy and light things mixed, and then just blow air, and the lighter things will just be removed. So something very similar, but it's done in a chamber. So what else? Magnetic we have already talked about. One important thing, this is something that I would like to discuss in more detail, is known as froth flotation. So flotation, you understand, the impurities should float, or impurities sometimes also your in the case of graphite, often because graphite is hydrophobic and graphite is light. So often it happens that the impurities that are mixed, that are heavier, and when you're doing any kind of separation, your graphite is the one that is actually floating. So then you can separate it out. However, what is a froth? Froth is a foam, foam that you get in your soap when you wash your hands. That is froth. So what you're going to do is you're going to create a froth. And if you have noticed that when you have froth, when you have bubbles in water, the hydrophobic impurities, the impurities that want to go away from water, they often get attached on the surface of these bubbles. So this is the fundamental principle that we are going to use here. So hydrophobic, now what you need is you need some frothing agents typically to promote, to make sure that you have bubbles, you have sufficient number of bubbles in your water. So that is number one, you need the frothing agents, and then you of course also, you may supply air separately, but you want to create this foam like material, and then which will take your material away. So this is how it looks like. Again, this is not a real image, this is just a representation. So you see that there is a chamber where you have let's say water, and in water you have this air inlet, so you're supplying air, and you may also have a frothing agent, so you have a foam. And now when you see that these are the white ones are the air bubbles here, and the black ones could be graphite flakes. Graphite, as I mentioned, is hydrophobic, so that gets stuck to your air bubbles, and then because they are air bubbles, they float. So this whole process is known as froth flotation process. Of course, you're constantly mixing it, and also you time to time you remove the froth, and then you further clean it. Okay, now afterwards the last steps are refining steps. So you can do some impurities are still left over, maybe there is some oily content, some leftover organic compounds in your rock. So in order to remove them, you can either clean the entire material with acid. If that still doesn't help, you can do roasting. So you can basically heat your material. You can also do roasting both in the presence of air and in the absence of air. So if you want to burn out the impurities, then you can do, don't heat it to very high temperature so it does not damage the graphite itself. So at reasonably low temperature, you can use in the presence of oxygen you can heat, so your impurities from the surface will get burnt. Also, you can sometimes then make sure that the temperatures are very high. In that case, you need to also control the amount of air that you provide so that you don't damage your graphite. Typically, graphite is very stable, so it's not a problem. Okay, you can also do certain microwave treatment, which you know, in order to get rid of the impurities. Okay, now other than these things, whatever I have mentioned today, you can also do electrostatic separation. The flotation, also the froth flotation, there are different variants of it. So there is something called film flotation. You can also read more about it. There are different types of flotation techniques. Okay, and then there is flushing. There are many other techniques that can be used so for refining or for processing of the graphite mineral. However, what is important for us and what takes us to sort of our next lecture is the fact that we have natural graphite, but number one, it is reasonably expensive. It's not so easy to because cleaning and its beneficiation can actually be reasonably expensive. So natural graphite is very expensive, and we also don't have much control, for example, on its properties. So if we have a flake graphite, then that's what we have. If we have a very large crystallites, then that's what we have. So we don't have very much control on the properties of the natural graphite. So in that case, we need alternatives. The applications are so many, but we don't have enough graphite. So alternative is synthetic graphite. Now, synthetically, it's easy to produce other types of carbons. Graphite, because of its unique crystal structure, because you need the 3D arrangement, that is actually relatively difficult, but we have processes that can be used for this purpose. So in fact, even making graphene is much easier compared to graphite. Because graphene, you will always get carbon flakes which are separated from each other. What is difficult is to give them this 3D crystal arrangement. For that, you need to provide it certain energy. So in the next few lectures, we are going to discuss how do we make synthetic graphite. Okay. Yeah, so as I mentioned, from carbonaceous materials, organic materials, from many different precursors, from polymers and so on, you can get your graphite, but not all polymers will work for this. So this is something we are going to discuss in our next lecture.